Good morning, students. So, in the last class, we studied how to find out the type of a molecule and how to write their structure. So, until I explain to what AB4 type molecule. So, today we will continue with the next. So, here, students, the next one is simply I will take the example. Later, I will tell you how to find out the type of a molecule. Okay. So, I will go with NH3 here. Okay. B with the chart what I gave in the yesterday's class. Okay, be with that chart, then only you can understand easily. So NH3. Here nitrogen is the central metal atom. So we need to consider valence electron for this nitrogen. So students, atomic number of nitrogen is 7. Configuration is 1s2, 2s2, 2p3. As these two are the shells having greater number of n value. 1 and 2 means this is the valence shell. Here how many electrons are there? 2 plus 3 means 5 valence electrons are there in nitrogen atom. Okay, so this one is. So nitrogen, how to find out the electron pair here? So number of electron pair is equal to valence electron minus bonded electron divided by 2. Okay. So how many valence electrons are here? 5. How many are bonded here? 3 divided by 2. So that is 2 divided by 2, 1 electron pair. Okay. So students, N means A, H means B. How many is right? 3 times. And 1 electron pair, that is AB3 E-type molecule. Okay, so students, AB3 E-type molecule means, of course, the standard structure for this is tetrahedral only. Okay, so this is A, that is nitrogen. Here lone pair electrons. Here 3 hydrogen atoms. This is tetrahedral structure. Okay. So students, here 1 lone pair is there and 3 bond pairs are there. And at the same time, there is a repulsion between these two. Okay. Between these and this. So the molecule is distorted. Then the bond angle is less than 109.5 degree. So actually here the bond angle is 107.5 degree. Okay, so less than 109.5. Why? Because one lone pair electron is there. Lone pair bond pair repulsion is more compared to bond pair and bond pair. So the bond angle is 107.5 degree instead of 109.5 because the tetrahedral angle is standard angle is 109.5 degree. Okay, so this is one example. Similarly, you take PF3. PF3. Okay, so of course the phosphorus atomic number is 15. Configuration is 1s2, 2s2, 2p6, 3s2, 3p3. So this is one shell, this is one shell, this is one shell, and this is the valence shell. Okay, so yes students, how to find out the electron pair means, of course, the 5 electrons are the valence electrons. Among 5, 3 are bonded. Divided by 2 means that is 1 electron pair. Understand? So now the P means A, F means B, 3 E. Of course, AB3 E type means that follows tetrahedral angle. As I told you, AB4, AB3E and AB2 E2. They follows tetrahedral angle. Okay, next. Here how to write phosphorus is here. and the 2 lone pair electrons are here, like this, and remaining 3 are fluorine atoms. Are you getting? So here also the bond angle is less than 109.5 degree. Always remember, so if any at least one lone pair is there, so there is a repulsion. Then the bond angle of actual structure decreases by its angle. It cannot be increases because repulsion is there means if the atoms are like this, they come closer and closer. Atoms are like this means they come closer. Then of course here the bond angle decreases. Understood? So this is a B3 E-type molecule. This is how to find out by doing this formula. So whatever the single atom is there, that is A here, and the bonded atoms, that is B here, and the remaining by the valence electron. From this formula we can easily calculate the electron pairs. Once we came to know, then we need whatever the chart I given. In that I give the list of this type of molecule. From that we can write them in a standard structures. Okay. So the next one is H2O. Okay. So among this, the single atom is oxygen. That is the central metal atom. So atomic number of oxygen is 8 and its configuration is 1s2, 2s2, 2p4. Okay, atomic number, right? 1s2, 2s2, 2p4, and this is the valence shell 2s2, 2p4. So students here, once we know that, then we have to calculate number of electron pair. What is the formula? Valence electron minus bonded electron divided by 2. How many valence electrons are there? 6. 4 plus 2, 6. So among how many are bonded here? 2. So divided by 2. So that is 4 divided by 2 and 2 electron pair. And students, this is A, this is B 2 times, and electron pair also 2 times. That is AB2E2. So this molecules also follows tetrahedral structure, the standard structure. Okay, just remember the standard structure. Later I will explain why it is called as band and why it is called as inverted wheel, everything. So tetrahedral structure. So students, now tetrahedral structure means here oxygen is there. Okay, one bond should be like this, this and this. Okay, they are in different plane. Remember here, instead of one lone pair here because 2 lone pair atoms. Okay, next another lone pair here. Lone pair atoms are there. They get, okay, there is more number of repulsion here. Initially in NH3 only one lone pair is there. As I told you, lone pair repulsion is greater than lone pair bond pair. So initially in NH3 only one lone pair is there. So lone pair bond pair repulsion is more. Here 2 lone pair atoms are there. Lone pair means which are not involved in bonding. So two electron pairs are here. So then the repulsion is more. Means if the atoms are like this, they gets completely come closer and closer to each other. Why? Because repulsion is more. These repulsion means these pull these bond pairs in inverted manner. So the structure is distorted. This will repulse like this will repulse like this. Similarly here also. And remember, they are not in the exactly, what is it? Uh, in two-dimensional structure, I represent them like this. But you know, actually tetrahedral structure is not like that. I already explained you. Okay, so these two are the planes. This is towards the observer and this one is away from the observer. This is actually the tetrahedral structure. I hope you can see easily. Okay, plane. These two are the plane. This one is towards the observer and this dark green one that is away from the observer. Okay, so if listen, one atom is here, another atom is here, are in the plane as well. Here, two lone pair electrons are there. They distort them, then they are repulsing. So they are come closer to each other. Now listen, it is exactly 90 degree. Sorry, actually it is not 90 degree. 109 degree, 28 minutes. 109.5 degree. So when the repulsion is more, they come closer, closer, closer like this. Then the bond angle decreases. So if it is like this, 90 degree, less than 90 degree. Okay, repulsion is more when their bond angle decreases. Here two lone pair atoms are there. So that's why the repulsion is more. Of course, the bond angle here is also less than 109.5 degree. So if you write this much, that is enough for your convenience. So but actually students, the bond angle between these two is 104.5 degree. Okay, this we are going to study in what? That hybridization later, another one. Okay, one second. Okay, so this is all about what? AB2, E2 type molecule. So the next one similarly, you just try yourself H2S. Your sulfur is having atomic number 16, configuration 1s2, 2s2, 2p6, 3s2, 3p4, and this is the valence shell. You just go through that molecule as it did here. Okay, and send that answer in the group. Today I will give at least 4 structure for your homework. You just do it and send it to me in the group. Okay, yeah, just as it is, it follows like that. Okay, so the tetrahedral structure is done. So the next one is trigonal bipyramidal. So before going to that, I'll take the example PCl5. PCl5. Okay, student, if PCl5 is there, here phosphorus is there, and here Cl5 is there. This is A, this is B. B is 5 times. Remember, initially we need to write the valence electron for phosphorus. Atomic number is 15. Configuration is 1s2, 2s2, 2p6, 3s2, 3p3. Okay. Now, so the number of electron pairs are number of lone pair electrons. Valence electron minus bonded electron divided by 2. So valence electron here is 5. So students, how to find out bonded electron? Remember why I am taking 3, why I am taking this one, PCl5, PCl3. Those represents the bond pairs. So this one PCl5 means 5 atoms of phosphorus are involved in bonding divided by 2. Okay, and it is 5 minus 5 means 0 by 2, that is 0 electron pair, means there is no electron pair. Then the phosphorus is taken as A, the Cl is taken as B, so this is AB5 type molecule. Okay, then what happens here? This is trigonal bipyramidal structure. Standard structure is trigonal bipyramidal. So in this trigonal, the bond angle is 120 degree. In this bipyramidal position, bond angle is 90 degree. I'll just represent the structure here. Phosphorus is like this. This is the atoms in triangular plane. And these are bipyramidals. Okay, that is Cl, Cl. How this atom exactly looks like, I will show you. Okay, so this is the triangular structure. I hope you can see like a triangle exactly. Okay, like this. In the plane I am taking triangle. One is above this, one is below this. This is the triangle. One is above, another one is below. This triangle, you can see is, it is greater than 90 degree means like this. So this atom is like this, greater than 90 degree, that is what? 120 degree. And this one, if it is in a plane, this is exactly perpendicular. Means this is 90 degree with this. So this is how the trigonal bipyramidal structure is. Are you getting? Triangle is in this shape, below the plane, above the plane. Okay, this is tetrahedral trigonal bipyramidal structure. Are you getting? So this is what PCl5 structure. One thing. So the next you take SF6. Okay, so here the sulfur atomic number is 16. Configuration is 1s2, 2s2, 2p6, 3s2, 3p4. This is the valence electron. So not SF6, SF4. Okay. Here students, how to find out number of electron pairs? Same, valence electron minus bonded electron divided by 2. So valence electron here is 6. Bonded electrons is how much? 4 divided by 2, that is 2 divided by 2, that is 1 electron pair. Students, here this sulfur is A, this fluorine is B. 4 times AB4 and the 1 electron pair, that is AB4E. Okay, so then now what happens? Of course, this is also follows standard structure trigonal bipyramidal. But the thing is, the structure actually is square pyramidal. Why? So listen, I'll simply represent sulfur is here. These are in a triangular manner. Just I am representing. Later I will say the exact structure. So another one pair is here. That is, you think yourself. Fluorine, 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 and this one is electron pair. Okay. For students, if electron pair is there, then what it will do? It repulse the structures in this manner. Okay. So then, what they will form? Instead of that, they form structure like this. Okay, so if we consider this lone pair electron, this is square pyramidal. If we consider this lone pair, it is square pyramidal. If we consider only bond pair, then it is square planar with bond pair. If we consider only bond pair, is square planar structure. If we consider this along with this lone pair, then it is square pyramidal, not triangular bipyramidal. So students here, of course here the bond angle decreases. Okay, here triangular shape is there, the triangular shape changes to square. Okay, so the bond angle is in between 90 and 120. Understand? This is how the structures are going to be explained. Of course, this is the standard structure is trigonal bipyramidal only, but due to repulsion, it changes the structure to some other structure, standard structure to some other. So listen, initially what I explained, oxygen. So I explained two lone pair electrons are there. Instead of that, it will be there, the bed. Then, if we consider all these two lone pair, then it is tetrahedron. If we are not considering this lone pair, then it is bent or inverted V shape. So by considering the bond pairs only, we can easily explain the structure. Either by considering this bond pair as well as lone pair, we can explain easily the structure. Both are correct. Bent shape is also correct. Tetrahedron shape is also correct. Understood? Okay. So what I am telling is, if the type of the molecule is there, you won't understand that type of structure. Just remember the standard structure. No matter where you are going to write the positions. Okay? Simply write the bond pairs as well as lone pairs in the standard structure, and you simply write the bond angle is less than the original bond angle. Because repulsion is more means the bond angle decreases. So this is one. Next. Another one, that is ClF3. So students, Cl atomic number is 17, configuration 1s2, 2s2, 2p6, 3s2, 3p5. So this is the valence shell. So how to find out the number of electron pairs? So then, number of electron pair is equal to, okay, so valence electron minus bonded electron divided by 2. So here the valence electrons are 7. How many are bonded here? 3 only divided by 2. So 4 by 2 means 2 electron pairs. 2 electron pairs. Now this here is A. This one is F is B, 3, E2. So students remember, another one thing I will clear you. If AB2 molecule is there, 2 are bonded, so linear. If AB3 and AB2E, including this 3 and 2 plus 1, 3. If 3 bonds are there, trigonal. And similarly, AB4, AB3E, AB2E2. Listen, 4 bonds, 3 plus 1, 4, 2 plus 2, 4. If the 4 bonds are there, including electron pair, tetrahedron. Next here, AB5, AB4E, AB3E2, AB2E3. Okay, here 2, so 5 and 4 plus 1, 5, 3 plus 2, 5, 2 plus 3, 4. So all are having got 5 bonds, including electron pairs. Then the standard structure is trigonal bipyramidal. Similarly, AB6, then AB5, AB4E2, AB5, sorry, AB3E3 and AB2E4. So all these having 6, 5 plus 1 6, 4 plus 2 6, 3 plus 3 6, 2 plus 4 6. So 6 atoms and 6 bonds including electron pair means that is octahedral structure. Remember, this is one easy way to find out actually the structure. Okay, so now here these are the short tricks we are going to use in NEET examination actually. But here I am explaining clearly to you people. In NEET, you won't have this much of time writing the valence electron, writing the bond pair electrons divided by 2 and that. Just a mind calculations. How? 7 electrons. Halogen means 7 electrons. 3 are bonded, remaining is 4. So divided by 2 means 2. That is, you should do in the mind calculation. That is very important for NEET examination. You won't write it on the paper because rough work is also not, they are not provide too much rough sheets also. Within the given space, you need to do the work. Okay, next. AB3, 3 plus 2 means 5. So this is also of course trigonal bipyramidal structure. Okay, there the structure changes to what? Square pyramid. So here I will take this Cl atom here and this F here and of course lone pair electrons here. Then this is of course trigonal bipyramidal. But student, when you consider this is trigonal bipyramidal. Just leave this structure, simply write the structure like this. Then it is what? Without considering this lone pair, this is trigonal planar. Means instead of this trigonal bipyramidal, the structure also follows trigonal planar. Of course, this is exactly one is above the plane, one is below the plane means the repulsion is equal, they gets cancelled, the bond angle is 120 degree only. Understand? Means the structure of this type of molecule instead of trigonal bipyramidal changes to what? Trigonal planar. That is instead of trigonal bipyramidal changes to square pyramidal or square planar. Okay? So the next one. Fixie. Students, you know, xenon is of course the noble gas and its valence electron. So this is krypton 5s2 5p6. So this is valence electron. Of course, the noble gas means we know 8 electrons are there. So students, how to find out the electron pair means valence electron minus bonded electron divided by 2. Okay. So what are the valence electrons here? How many? 8. How many are bonded here? 2. Divided by 2 means, so 6 by 2, that is 3 electron pair. Okay. So xenon is A here and this F2 is B here and 2 are bonded. and electron pairs are 3. AB to E3. So students here 3 plus 2 means 5 atoms, that is the standard structure is trigonal bipyramidal. But actually what the structure changes is, try to write the atom length. Xenon, 2 atoms are here, fluorine, and one lone pair is here, another lone pair is here, and another lone pair is here. Means the lone pair atoms are trigonally arranged, and these are in the bipyramidal form. So if you just twist the molecule, so this one is what? Trigonal bipyramidal. So students, I'll just rotate the molecule here. Xenon, fluorine, one lone pair, another lone pair. Okay, this is what I just rotate this molecule by 90-degree angle. So trigonal bipyramidal. Okay, so if you consider the lone pair, this is trigonal bipyramidal. If you just remove this lone pair, then the structure is what? Linear. If we consider only bond pair, the structure of the atom is linear. Understood? This is how to find out the actual structure. You may represent in a standard form or in the distorted form. This is the distorted form. The structure may be trigonal bipyramidal, that is also correct. Linear, that is also correct. But you have to mention linear with 3 lone pair of electron and square planar with 1 lone pair of electron, like that. Okay, so this is all about atoms having 5 bonds: AB5, AB4E, AB3E2, AB2E3. Understand? So the thing you need to remember is what? Just to consider the number of bonds. Later I will give one. What is it? List for you people for which bonds, how to calculate or how to consider the respective structure. Remember, for 2 bonds, linear. For 3 bonds, trigonal. For 4, tetrahedral. For 5, trigonal bipyramidal. For 6, octahedral. That's enough. So no matter whether it is an electron pair or a bond pair. Understood? Consider both of them. If it is equal to 4, then it is trigonal. If it is equal to 5, trigonal bipyramidal. That is the standard structure. Okay? So next we will move to okay. The next one is S6. Okay. So students here, sulfur atomic number is 60. Of course, I won't consider it again and again. Sulfur, it belongs to oxygen family. So the valence electron of sulfur is 6. I won't write it again. Configuration. The valence electron of sulfur is 6. Next, number of electron pair is equal to valence electron minus bonded electron divided by 2. So valence electrons are 6 here. Bonded electrons also 6 here. Divided by 2, that is 0 electron pair. Then S is taken as A, F is taken as B, AB6, that is octahedral structure. How to write? Sulfur is here and the bonds are like this. Okay. So students, here the bond angle is 90 degree. All the bond angles are 90 degree. How the structure is actually is like this: 1, 2, 3, 4, 5. Another one is 6. Like this. Exactly 90, 90, 90, 90. I hope you can see easily. Octahedral structure. Like this. Are you getting? Exactly 90 degree with respect to each other. So these are in the plane, this is also perpendicular. But they are exactly 90 degree to each other. So this is one. How to find out the structure? 6 atoms are there, then octahedral means 6 bonds. Next, you consider C atom. We are 5. So students, this is an halogen. So valence electron is how much? 7. Number of valence electron in this halogen atom is 7. No matter which is chlorine, bromine, iodine. In all these, halogen means 17th group elements, its valence is of how much? 7. Okay, remember I will give one hint. So if it is first group element, valence is 1. Second group, valence is 2. Third, valence is 3. Sorry, 13. 14 valency 15 valency 16 valency 6 17 valency 7 18 means valency 8. What is it? Valence electrons, number of outermost electrons. You remember this. So one which is belongs to. Once you know that, what is that? Family. Like P block elements you know. After oxygen is there, sulfur is there, selenium is there. So instead of SF6, if they give SCF6, then also you need to take 6 also because in the same group, valence electrons are same. Understand? The same thing is happening here. Now listen. Valence electrons are 7. So the number of electron pair is equal to valence electron minus bonded electron divided by 2. So how many valence electrons are here? 7. Bonded is how much? 5 divided by 2. So 2 by 2 means 1 electron pair. Okay. Now students, Cl is P. This B is 5 times and 1 electron. AB5E. So A is the central metal atom. 5 bond pair, 1 lone pair. 5 plus 1, 6. So this is also octahedral structure. But it changes. So how the Cl atom is here? Of course, the structure of octahedral is like this. Fluorine atoms are bonded here, and here one lone pair is there. Then student, if you consider this complete structure, that is octahedral. Arrangement is of course octahedral. But without this lone pair, the structure is what? Square pyramidal. That is square pyramid. Here, the bond angle is less than 90 degree because the repulsion is there, the repulse is there, then it is square pyramidal structure. So don't worry about the bond angle, just see the difference. Octahedral, when we consider the lone pair electron, if we didn't consider the lone pair electron, only considering bond pair, I will represent here. This is square and this one is pyramidal. Okay, this is what? Square pyramidal structure. Okay, so next, another one example is HCl. Okay, of course, xenons The valence electron of this is 8. So the number of electron pair, that is valence electron minus bonded electron divided by 2. So valence electron here is 8. How many are bonded here? 4. So divided by 2 means 4 by 2, that is 2 electron pair. So students, here atom is A, this one is B 4 times, and the lone pair electron is E2. Okay? Now here AB4E2, 4 plus 2 means 6. This is also octahedral. Okay, so instead of that, if you write xenon here and the 4 bonds here, so 6 bonds here, this is fluorine, 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 fluorine. Okay, next here, one longer. So students, if you consider this lone pair of electrons, so I simply write like this, including one pair. If you consider the lone pair of electrons, this is octahedral in structure. If you consider only bond pairs, then it is square planar. Okay, when you consider this is square planar structure. Are you getting? This is how to find out the structure. Okay, so students, the next type of molecule, of course, still they did not exist, and I don't find any example for those. So you just go through this. So if the 6 electron pairs are there, remember then they are said to be a octahedral structure. And remember AB3E3 and also AB2E4. For such a type of molecule, we won't have any example because to get AB4E, I will write here AB3E3 means 3 bond pair, 3 lone pair means plus 6, there are 9 electrons. So the maximum valence electron presence in the outermost shell is only 8 in the noble gas. Later it is again changes to 1, 2, 3, 4, 5, 6, 7, 8. That completes. Okay? And at the same time, AB2E4 also. Okay? So for this type of molecule also, here 2 plus 8 means 10 electrons we want. Okay, so now we don't have such type of examples. Of course, if we consider the d block elements, for example, 10 electrons means Fe you may take. Fe means atomic number is 26, configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. So this is the valence electron, 4s to 3d6. So later you take nickel, that is 28. Okay, that is 8. Then it is 10 electron system. Cobalt if you take, that is 27. Outermost configuration 4 is to 3d7, that is 7 electron. But these exhibit the structures based on hybridization, not based on valence bond theory, because in valence bond theory we are considering these as a valence electrons, not 4s2. Are you getting? So that's why. So I won't get any example for Ab2, E4 and Ab3, E3 type molecule. If I get at that time, I'll explain. Because why we are not getting any example? The maximum number of valence electron in the outermost shell is only 8. That's why. Okay? Thank you. In the remaining, what is the chapters we will discuss in the next class.